1. Choose the correct statement. The primary difference between solids and liquids is that the constituent particles are I. Closely packed in solids, while they are stationary in liquids. 2. Far apart in solids and have fixed position in liquids. 3. Always moving in solids and have fixed position in liquids. 4. Closely packed in solids and move past each other in liquids. Answer. 4. Closely packed in solids and move past each other in liquids. Question number 2. Which of the following statements are true? Correct the false statements. 1. Melting ice into water is an example of the transformation of a solid into a liquid. True. 2. Melting process involves a decrease in interparticle attractions during the transformation. True. 3. Solids have a fixed shape and a fixed volume. True. 4. The interparticle interactions in solids are very strong, and the interparticle spaces are very small. True. 5. When we heat camphor in one corner of a room, the fragrance reaches all corners of the room. True. 6. On heating, we are adding energy to the camphor, and the energy is released as a smell. False. On heating camphor, particles gain energy and spread as vapor, not released as smell itself. Question number 3. Choose the correct answer with justification. If we could remove all the constituent particles from a chair, what would happen? 1. Nothing will change. 2. The chair will weigh less due to lost particles. 3. Nothing of the chair will remain. Answer. 3. Nothing of the chair will remain, because the chair itself is made of particles. All matter, including the chair, is made up of tiny constituent particles. If we remove all these particles, there would be nothing left because the entire structure of the chair is built from them. Without particles, the chair cannot exist at all. Question number 4. Why do gases mix easily, while solids do not? Answer. Gases mix easily because the particles of gases are very far apart and move freely in all directions. The large interparticle spaces and negligible forces of attraction allow gas particles to spread and mix quickly. In solids, however, the particles are tightly packed with very little interparticle space and strong forces of attraction. The particles can only vibrate in fixed positions, so they cannot move freely to mix with other solids. Therefore, gases mix easily, while solids do not. Question number 5. When spilled on the table, milk in a glass tumbler flows and spreads out, but the glass tumbler stays in the same shape. Justify this statement. Answer. Milk is a liquid. Liquids do not have a fixed shape, they take the shape of the container they are kept in. When spilled on a table, the milk flows and spreads because the particles of a liquid are loosely packed and can move past one another. However, milk still has a fixed volume. The glass tumbler, on the other hand, is a solid. Solids have a fixed shape and a fixed volume because their particles are tightly packed and strongly held together. That is why the tumbler retains its shape even when the milk inside it does not. Question number 6. Represent diagrammatically the changes in the arrangement of particles as ice melts and transforms into water vapor. Answer. This is figure. Ice, solid particles tightly packed water, liquid particles slightly apart water vapor, gas particles far apart and moving freely. As ice melts and turns into water vapor, the particles gain energy, move farther apart, and their movement increases, changing the state from solid liquid gas. Question number 7. Draw a picture representing particles present in the following. I. Aluminium foil. 2. Glycerin. 3. Methane gas. Question number 8. Observe Fig. 7.16. A which shows the image of a candle that was just extinguished after burning for some time. Identify the different states of wax in the figure and match them with Fig. 7.16. Be showing the arrangement of particles. Gas. Liquid. Solid. Solid wax, candle body, liquid wax, near wick, gaseous wax, vapor-giving flame. Question number 9. Why does the water in the ocean taste salty, even though the salt is not visible? Explain. Answer. Ocean water tastes salty because it contains dissolved salts, mainly sodium chloride, NaCl, and other minerals. When salt dissolves in water, it breaks down into tiny particles, ions, that mix evenly with the water particles and occupy the interparticle spaces between them. These salt particles become so small and spread out that they cannot be seen with the naked eye, but they still give the water a salty taste. Therefore, ocean water tastes salty even though the salt is not visible. Question number 10. Grains of rice and rice flour take the shape of the container when placed in different jars. Are they solids or liquids? Explain. Answer. Grains of rice and rice flour appear to take the shape of the container, but they are actually solids. Each grain of rice or each particle of rice flour has a fixed shape and volume. When many such solid particles are poured into a container, they just settle close to each other, leaving small gaps between them. This collection of solids only seems to take the container's shape because the particles can move past one another slightly, but the individual particles themselves do not change shape like liquids do.